I hope you have watched the last video on how lines can be parallel to plane. In this video, we are going to focus on if lines are not parallel to plane, how can we find the intersection point of the line and a plane? Okay, so let's say L is given as, so here a line is given and the Cartesian equation of a plane is given. We know if Cartesian equation of plane is given, we can find the normal vector. So n can be given as 3, 2, and 7. Okay. So first of all, we have to check whether this line is parallel to the given plane. Okay. So let's name the direction vector as b. So b will be equals to 3, 4, and 2. So first of all, we have to check b dot n. So b dot n will be equals to 3 into 3 plus 2 into 4 plus 7 into 2. So let's see how much this will be equals to. So this will be equals to 9 plus 8 plus 14. So definitely this is not equals to 0, which implies b is not parallel, not perpendicular to n. So this implies b is not parallel to plane pi, which implies line L is not parallel to plane pi. So now we can actually find the intersection point of line L and pi. So if you have the Cartesian equation and the vector equation of a line, so what you have to do is, first of all, you have to come up with the parametric equation of the line L. So for L, the parametric equations will be, well, we can say x is equals to 2 plus 3 mu and y is equals to 3 plus 4 mu and z will be equals to minus 4 plus 2 mu. Okay, so that's what we have. Perfect. So why do we need the parametric equation? Okay, that's the question here. Why do we need the parametric equation? Well, think of this. Okay, think of this, because if a plane is present, okay, let's say this is the plane phi. Okay, since the line L is not parallel to the given plane, that means it is intersecting the given plane. Yeah, it is intersecting the given plane, and it intersects at a given point. Okay, it intersects at a given point. The beauty of this is the point P lies on L as well as lies on phi. Okay, if it is intersecting, the point P lies on L as well as on the plane phi. Therefore, we can substitute the parametric values for x, y, and z in phi to come up with the point. Okay, so if we substitute the parametric values, we will find the value for mu. Then we can find the x, y, z coordinates of point P. Okay, so let's substitute that. So that will be 3 into 2 plus 3 mu plus 2 into 3 plus 4 mu plus 7 into minus 4 plus 2 mu plus 3. Okay, this is equal to 0. That's the equation of the plane. So that will be equals to 9 mu plus 8 mu plus 14 mu plus 6 plus 6 minus 28 plus 3 is equals to 0. So totally we have 9 plus 8, 17, 17 plus 14, 31 mu. 31 mu will be equals to 6 plus 6, 12, 12 plus 3, 15, 15 minus 28 minus 13. When you bring it to the other side, it will be plus 13. So mu will be equals to 13 over 31. Now we know the value for mu at which point P lies on L as well as the plane phi. So now I can substitute the values. So x will be equals to 2 plus 3 into mu. So that will be 39 over 31. And y will be equals to 3 plus 4 into 13 will be 52 over 31. Okay. And then we have z, which is minus 4 plus 2 mu, which is 26 over 31. Okay. Now you can use your calculator to find the answer. Obviously, you can use your calculator to find the answer. But yeah, this is the basic idea that we are going to use to find the intersection point of a given plane and a line. Okay, that's all. Now let's do another question. In this question, you can try to do it by yourself. But the thing is, here we don't have the Cartesian equation. We have the vector equation. So how can we find out the Cartesian equation? I have already explained it in a video. I will attach to this video also. But I'll just go through the basic idea. First of all, we will define the direction vector. So that will be 2, 4, and 3. Okay. and another direction with vector will be C, which is given as 3, 2, and 7. Now you have to find the normal vector. It's pretty simple. Normal vector will be equals to B cross C or C cross B. Okay, order doesn't matter when you're finding the perpendicular vector or the normal vector. So how do we do the vector product? I will also attach the video for that. But here I will just use the idea that we have learned until now. So IJK. So here we have B first. So that will be 2, 4, 3, and then 3, 2, 7. Okay. So here we will have I into 4 into 7, 28. 28 minus 3 into 2, 6. Minus j into 2 into 7, 14. Minus 3 into 3, 9. And then we have plus k into 2 into 2, 4. Minus 4 into 3, 12. So you will get 22i and minus 4. So it will be minus, 5 minus 5j. And then we have minus 8k. So this is the normal vector. So normal vector can be given as 22 minus 5 and minus 8. Yeah, looks simple enough. So this is what you have to do. Now, since we know the n and we also know a point, the position vector of a point on the plane, that can be given as a equals to 3 minus 1 and 2. Okay. So now we can come up with the vector equation. So sorry, the Cartesian equation. So r dot n will be equals to a dot n, and in this case r will be x, y, and z. N is given as 22 minus 5 and minus 8, and a is given as 3 minus 1 and 2, and n is again 22 minus 5 and minus 8. So you can come up with that it as 22x minus 5y minus 8z is equals to 66 plus 5 minus 16. So this is equals to 55. So now we have to come up with the parametric equations to find the intersection point. Yeah. So before we find that out, first of all, let's check whether the line is parallel to the given plane. Okay. So for that, we have to check this out. So let's say this is equals to D. So D is given as 4, 5, and 6. Okay. So D dot N will be equals to 22 into 4 minus 5 into 5 minus 8 into 6. So that will be equals to 88 minus 25 minus 48, which is not equal to 0. So we can definitely say D is not perpendicular to N. So therefore D is not parallel to plane phi, which implies D is not parallel to plane phi, which implies that line L is not parallel to the given plane phi. So now we can use this to find the intersection point. So first of all, let's come up with the parametric equations for the line L. So for L, we will have the parametric equations as x equals to 1 plus 4 lambda, y equals to 2 plus 5 lambda, z equals to 3 plus 6 lambda. Yeah, this is what we need. Now we will replace the values for the Cartesian equation of the plane, which is phi is equals to 22x minus 5y minus 8z is equals to 55. So I will erase this area since we have already come up with the important things from that. So 22 into 1 plus 4 lambda minus 5 into 2 plus 5 lambda minus 8 into 3 plus 6 lambda is equals to 55. So 22 into 4 will be 88 lambda, minus 5 into 5 will be minus 25 lambda, minus, minute, minus 25 lambda, and minus 8 into 6 will be minus 48 lambda, and then we have plus 22, minus 10, k, plus 22, minus 10, and minus 24 equals to 55. So this will be 40, 15 lambda is equals to 55 plus 24, 79, 79 plus 10, 89, 89 minus 22 will be 67. Yes, it will be 67, right? Shall we check? So minus 2, and then we have minus 67. Yeah, yes, it will be 67. Okay, cool. So what should we do next? then lambda will be equals to 67 over 15. So now we know x is equals to 1 plus 4 into 67 will be 24 to 68 over 15. Y will be equals to 2 plus 335 over 15. Then z equals to 3 plus 36402 over 15. Okay, so this is what we have. Okay, so that's it. That's it. That's all we need. Yeah, that's all we need. And yeah, we can use the calculator to find the points accurately. But I'll just stop it here. So this is what we have as the interactions between a line and a plane. In the next video, we will be focusing on two planes. So definitely stay tuned.
Thanks for watching the 34th video in our vector series. If you found this explanation of finding the intersecting point between a line and a plane helpful, don't forget to like, share and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.